welcome to this Nipoppy tutorial. In this tutorial, we will cover how to create a new Nipoppy dataset. More concretely, we will run the Nipoppy init command, discover the directories that follow the Nipoppy specification, explore the Nipoppy status command, modify the content of the manifest.tsv file according to our dataset, and run the track-curation regenerate command. To participate in this tutorial in a hands-on fashion, you will need a Python environment containing an installation of the Nipoppy toolbox. You can either use Conda or Python virtual environments for this. Either way, please make sure to verify successful installation. You will also need an imaging dataset. For this tutorial series, we provide an example dataset in a GitHub repository, which you are welcome to use. If you are new to Nipoppy and watching this series for the first time, we recommend to use the provided example dataset instead of your own in order to experience a first full use of Nipoppy without any dataset-specific errors. Please download this example dataset and keep it in your working directory. Once you've done this, we can start with the first Nipoppy command. Nipoppy init creates what we call the Nipoppy dataset. Datasets created with this command follow the Nipoppy specification for dataset organization, which helps us to execute all the steps in our study, starting from data acquisition to extraction of IDPs. If we are starting to use Nipoppy during or shortly after the acquisition stage, we are very likely to have our study data in an unorganized DICOM or NIfTY format. In this case, we just need to specify a name for our new Nipoppy dataset without any additional flags. Nipoppy also takes into account that not all studies start with unorganized data, but might use datasets which are already in bit standard. If we are initializing a Nipoppy dataset with a bits dataset, we can pass the additional bit source flag. This will symlink the existing bits dataset to the bits directory inside our Nipoppy dataset. If you want to move or copy the data instead, you can do so by passing the mode flag. We can check out the available flags by typing Nipoppy init -h. No matter if we start with an unorganized source or a bits dataset, as soon as we run the Nipoppy init command, we see in our terminal that Nipoppy is creating all the directories which are defined by the Nipoppy specification. As soon as we see the message successfully initialized Nipoppy dataset, the init process is completed. In the following tutorials, we will take a closer look at each of these directories, especially the container store, pipelines, the source data, and the bits directory. It is important to know that all further Nipoppy commands expect all these directories to exist. Nipoppy also provides you with a command that lets you check the status of your dataset and processing actions anytime. It is a good practice to run this command often, since this is a nice way of doing quick sanity checks as well as recognizing potential debugging points early. The first part of the Nipoppy status output is a summary of the manifest file. We explain in the What is the manifest file tutorial that a template manifest is created by Nipoppy init. When we initialize a new Nipoppy dataset, like we did just now, it is our responsibility to populate this file with the correct and complete information for our imaging data. This is why we don't see the correct information about our example dataset here, but the information from the template manifest file. Importantly, the manifest file is considered the ground truth for collected data and is relied upon by all subsequent Nipoppy tasks. If you start from a bits dataset, Nipoppy already populated this file with information for the imaging data in your dataset. You should still inspect the file for possible errors or missing information. Nipoppy further created a file called curation.tsv. This file is explained in our What is the curation status file tutorial. As its name implies, this file keeps track of the curation status for the source imaging data of each participant. Nipoppy status also checks for the global config file. We explain in a tutorial dedicated to this file what this file is about, but please keep in mind for now that this is the file that holds important central configurations for executing processing actions on your Nipoppy dataset. Next, we are told that we do not have a processing status file yet, which makes sense because this file is related to processing pipelines and we did not do any processing on our imaging data yet. We will learn in a later tutorial how to do this. Finally, Nipoppy status gives us a summary table for the status of the imaging data in this dataset. Now, let us modify the information in the manifest file according to our example dataset. We open the manifest.tsv file and replace the template with the actual data for our dataset. Our example dataset comes with in total 4 subjects. All subjects have a baseline visit, which in our case is the same as the imaging session. The first 2 subjects have T1-weighted anatomical images, resting state and diffusion data. The third subject has anatomical and functional, and the fourth subject has only anatomical data. To finalize the updates on our dataset, we run the Nipoppy track-curation regenerate command to update the track-curation status with our true subject and session information. This will also update the Nipoppy status command, which we can see if we run Nipoppy status again. As a general note, you can always pass the dataset flag for Nipoppy commands. However, if your current working directory is the directory of the Nipoppy dataset, you don't have to. Congratulations! You are now ready to prepare your Nipoppy dataset for the use of containers.